Hi, my name is Katie, and I'm the driver for the session, and I'm here with.
Sibusiso, I'm the navigator of this session.
Okay. Okay. So over here we are going into chapter two, which was beginning the data exploration. With select. So I'm not gonna read over everything. There is a try to self activity that I will be doing, which basically goes through what the chapter was basically about. So first off, we've got the activity. So try to self-explain basic queries like these exercises. The school district superintendent asks for a list of teachers in each school. Write a query that lists down the schools in alphabetical order along with the teachers ordered by last name A to Z. And then number two, okay, I'll go over number one right now. Just get my database. So first of all, we've got the select asterisks from public teachers. This just views all the columns and rows from teachers table inside the public schema. So let me see how. So when I run this, let me just see something. We can see all the teachers. I also created a snack column for each teacher. So each teacher has a favorite snack, and I also added a else. The else is just so granola bars can appear. So I'll read the questions and then write a query that finds the teachers whose first name starts with the letter S and earns more than $40,000. Rank teachers hired since January 1st, 2010, ordered by the highest paid to lowest. So here we've got number two. This just finds the teachers whose name starts with the S and whose salary exceeds 40,000. So here we've got select from teachers where first name likes S and salary. So this filters the name starting with the S, the percentage symbol over there, and then this just ensures that the salary is over 40,000. So when I run this, we will see the list of sorry, we will see the list of teachers who earn more than 40,000, and there it is. And as we can see, the salary as well. Then moving on, we have number three, list schools alphabetically, showing each teacher's name in alphabetical order by last name. So here we have the select school, first name, last name from the teachers ordered by schools in. So let's just source a school in alphabetical order, and it also sources the last name in alphabetical order. So when I run this, we shall see the output. Here is all the schools, and as you can see, it is in alphabetical order. And as you can see, the last names is also in ascending order as well. Moving on, we've got number four, which is show teachers hired since January 1st, 2010, ranked by the salary from highest to lowest. So we've got the select first name, last name, higher date, salary from teachers. So where higher date, 2010, first and first, which filters the teachers hired in 2020 or later. And then we have the order by salary, descending order. So this just ranks the salary highest paid first. So I'm going to run that and we should see the output. And there we have it. These are the people that were hired and their salary. So that is it for chapter 2, and then we will be moving on to chapter 3. So chapter 3 is about understanding data types. We also have an activity here as well. So the try to sell says continue exploring data types with these exercises. Your company delivers fruit and veggies to a local grocery store, and you need to track the mileage driven by each driver each day to a tenth of a mile. Assuming no driver would ever travel more than 999 miles a day, what would your appropriate data type for the mileage column in your table and why. Um, in the table listing each driver in the company, what are the appropriate data types for the driver's first and last names? Why is it a good idea to separate the first and last names into two columns rather than having a larger than a column? Assume you have a text column that includes strings formatted as dates. One of the strings is written as for 2017. What will happen when you try to convert that into a string timestamp is a data type. So moving on, we've got our SQL. Here I created a table for the drivers. This is just to track the deliveries. So this ID serial primary key is auto incremented ID for each driver. And then the first name varchar, the first name string is a reasonable max length. And then we've got the last name. So the last name just is kept separate for sorting and filtering. I am reading online 6 now. So and then we've also got the mileage. So this is just a daily mileage accurate to one decimal max 999.9. And then on line 7 the delivery date. So the text field for inputting raw and messy dates. And then when I run that, the table will then be created, and then I have the select asterisk from drivers. This just allows me to see the table. As we can see over here, we've got Sarah, James, and Evie. And then now we are inserting the drivers with various mileage and delivery dates, which one will be intentionally broken. So here we have the inserted drivers, the first name, the last name, the mileage, and the delivery date values. So we've got Sarah, James, Evie, the mileage, and the date. So this is just for a valid date string, and it's a malformed date format causes the convention error. And then we've also got the clean and format for the success conversion. So let me run this. Okay. How do I view it though? Hmm. Moving on, here we will see the table for it. So let me just run it. As we can see, here are the names and then the mileage and the delivery date. So here we are going to attempt the cast the delivery date to the proper timestamp in the format of the error. So this is where the error should be expected to happen. When I run it, obviously here we've got our error. So obviously the value must be an integer. So let me fix that real quick. And the fix was to actually replace it with an actual date and an integer. I've already done it, I've ran it, and now we can see that that obviously does now appear on our table. And that is it for chapter 2 and 3. Thank you for watching.